Okay, moving on to the next one. It says using the energy practice data set and the standardized function, create a column for the z-scores for all gasoline price data, then sort from least to greatest by price. Okay, here's our energy data. And one thing I like to do when dealing with data is get rid of information I'm not going to use. Okay, so I can get rid of this kind of stuff here. I don't need this box down here. It just cleans it up a little bit so you don't have to worry about information that's irrelevant. Okay. Now, in this particular question, I'm being asked to look solely at gasoline prices. So I could go ahead and get rid of this data as well. Okay. So let me go ahead and do that. So now we've got years and gas prices. Now what I want to do is create a column for z-scores. And remember, z-scores are the number of standard deviations that a particular data point lies from the mean. In order to get z-scores, we're going to use a function in Excel. It's called the standardized function. In fact, the act of standardizing is creating z-scores, converting raw data into z data. And if you want to use the standardized function, you can pull it up here, you'll see that you need certain pieces of data. So our x is going to be each data point. Well, that's what we're going to have right here, because B2 will be our first gas price. And then we need the mean. We don't have the mean, so we're going to have to put a placeholder here. We're also going to need the standard deviation. We don't have that, so we're going to put a placeholder here. Okay. So right now, we're not going to get any calculation. But once I calculate my mean and my standard deviation, that should fill in. So let's do that. Put the mean here. We know that's the average function. Scroll over my data. So my average gas price is going to be $1.69. Okay. And then the standard deviation, we know that we use standard deviation.s for sample. And same idea, the standard deviation of our data is 0.7. Now we've got a z-score. Okay, this particular value, 1.07, lies 0.88 below the mean. I'm sorry, lies 0.88 standard deviations below the mean of $1.69. Now we can drag this down, but to do that we are going to need to lock some cells, because in our formula here we want B2 to drag down, right, to B3, to B4, to B5, etc. But we don't want B18 to drag down, so we're going to lock that. And we don't want B19 to drag down, so we're going to lock that. And then we can pull this function all the way down, and voila. Now the question asks us to not only create the z-scores with the standardized function, but to then sort from least to greatest. So we're going to take our data here, and we're going to sort based on the gas price from least to greatest. Okay? Gas price, smallest to largest. And look what happens. So $1.07 is the low, and the high is $3.30. Notice that when we sort the gas price from lowest to highest, we actually automatically sort the z-scores from lowest to highest, which should make sense because the z-scores are just another window of looking at the data. Instead of looking at this data as gas prices, we're looking at this data as gas prices relative to the mean in terms of standard deviations. So $1.07 is 0.88 standard deviations below the mean. $1.39 is 0.42 standard deviations below the mean, and $3.30 is 2.29 standard deviations above the mean. So if you sort this from least to greatest, you automatically sort the z-scores from least to greatest. All right, so we will be using z-scores and standardizing later on in the course. It's going to be very helpful to convert our data into z-scores and then use the z-scores to better understand how that data is distributed. Let's move on to the last one. It says, using the electronics practice data set, calculate the correlation coefficient and covariance for the two variables. So for this one, we're going to pull our data here. And what we want to do is find the correlation coefficient and covariance. Now, there's the long manual way of doing this, and there is the Excel quick, expeditious way of doing it. Let's use the manual method just to illustrate for practice, and then we will go in and do the Excel method and see if we get the same results. Let's start with the covariance, because we know from previous slides that the covariance actually factors into the correlation coefficient as the numerator. So let's start with the covariance. First thing we need is to look at the data. We've got weeks here, number of commercials, and sales volume. Okay, so you get a sense of what the data is. This might be something to do with a business that has purchased airtime over certain weeks for marketing, and they have acquired a certain sales volume. Okay. Now, optimally, they probably want to see that if they're spending more on commercials, that is, they're doing more commercials, they're going to have higher sales volume. So we probably want to see a positive relationship, a direct relationship. The covariance will help us see if that's the case. But to do the covariance, we're going to need to get averages first for both our x and our y. In fact, let's label these. I mentioned this before. Let's call this our x variable, and let's call this our y variable. You know, it doesn't matter which is which, as I said before, but it does help us stay consistent. Let's now find our mean, okay? And we know how to do that. The mean of number of commercials right there, and then the mean of sales volume right there. So mean number of commercials is 3, and the mean number of sales is 51. Probably in thousands. You know, you never know though, because it doesn't specify. For our next column, we are going to find the x values relative to their mean. So we're going to create a formula equals each x minus the mean. Okay? And what we need to do is lock this one because we don't want it to move as we pull it down. Drag that down, and we have it. So for example, this value here, 1, lies 2 below the mean, right? 1 is 2 less than 3, so on and so forth. Now let's do the same thing for the y values. Find out how far each of our y's differ from their mean. Okay? And again, let's lock the cell like that, and then drag that one down. Okay? So for example, this one, 57 is 6 less than the mean of 51, right? 57 minus 6 is 51, that kind of thing. Next thing we need to do is multiply these together. And we do that for all of these. Okay. And then once we do that, we're going to sum all of them. And you get 99. Okay. Now, this is a sample, so we're going to take that 99 and we're going to divide it by n minus 1, which is 9. And you should get 11. So that should be our covariance. Okay. Of course, let's check that. This is the manual method, right? Now let's do the Excel method. Covariance. And for that, we're going to put equals covariance for a sample, And let's pull up the window here. And our first array is going to be number of commercials. Second array is going to be our sales volume. And you get 11. So either way works. Of course, this is the one you want to do once you understand what's happening. Now, for those of you that don't recall from another video how I use this formula, it's this one right here. Okay? You can go back to that and visit the prior video if need be. All right, let's keep going. Now we need the correlation coefficient. So for that, we're going to do a manual method first. Okay? And then we'll do the Excel. The manual method is quite easy once you have the covariance, right? You're just going to take the covariance and you're going to divide that by your standard deviations for each of your variables, x and y. We don't have those yet, so we'll put placeholders in here. We're going to take this, we're going to multiply it by this, and that should give us the number. So let's put our standard deviations in here. Standard deviation for commercials, and then standard deviation for sales volume. And voila, we have our correlation coefficient. If we want to use Excel, we can then just put equals Corel. And again, we're going to need to pull up the argument box. Our first array is going to be commercials. Our second array is going to be sales volume. If you do that correctly, you should get the exact same number. Excel is easier, so we generally use that. Now, what does this information tell us? Well, for the covariance, because we have a positive value, we know that there is a direct relationship, which is what the business probably wants, right? You want more commercials, more sales volume. But it's not easy to interpret the covariance any more than just it's positive, so there's a direct relationship. What gives us more nuance is the correlation coefficient, because that tells us how strong that positive relationship is. And it's 0.93. Remember, the correlation coefficient has a scale from -1 to +1. And so a positive 0.93 is really close to +1, meaning that this is a very strong relationship. All right, that wraps up our Excel practice. If you have questions, let me know. Thanks.